Hi everyone, welcome back to 253, Process Troubleshooting. We're again on Chapter 5, Distillation Process, and we're covering Part 3, which is the troubleshooting. Okay, so we looked at process description and the operation and troubleshooting a distillation process. So you should have in front of you your schematic on page 527. You should also have 529 and 531, which are all of the other conditions in the instrumentation list. So we're going to use our troubleshooting steps again and our tools to solve the problems. So our tools are material balances, energy balances, interrelationship of variables, what's expected, the time factor, process knowledge, and knowledge of heat transfer principles. Then what we do is we troubleshoot through these steps. We collect all the data that we see in front of us. We evaluate that data. We then decide whether or not we have a problem by making a judgment. We list all the possible causes from instrument, mechanical, and process related. Then we look at all of this information. We decide what makes the most sense. And then we execute and plan a corrective action that would require the least amount of downtime and the best safety involved. Okay, so here's our chart again, and that's what we just talked about. All right, so we have exercise 5.1 and 5.2 in your book. The normal operating conditions are listed here. And again, like I said, I would have them in front of you as we're going over this. Okay, now let's look at exercise 5.1, abnormal operating conditions. This is on page, hold on a second, 5-41. All right, so now we're going to look at all of the numbers here and we're going to list them and just sequentially go down and put in our chart. So you would also, it'd be good to have that troubleshooting methods paper in front of you as we're filling this out. So let's look. Okay, we're going to collect our data. So FIC 40, that is the flow to the steam to the reboiler E3, that is up. The controller output is up. They're up 13,500 pounds and 15%. LIC 41 is up to 100% and the controller output is up 15%. So what that's telling us is that these two are linked together. Remember, cascaded. So if this is out, if this is up, this should be up. FIC 42 is the reflux to column D1. That's normal. PIC 43, which is the column top pressure, that is reading normal, but its output is down. The controller output is down by 5%. LIC 44 is the level in the reflux drum. That is okay, but the output is down 40%. So it's closing the valve output. FIC 45, which is the column's bottom flow, is down 3,700 pounds per hour and its controller output is down 25%. The differential pressure across the whole column, PDI 46, is down 3 pounds from the normal 8. And then FI 47, which is the overhead products to storage condensate liquid flow, is at is down 1,300 pounds per hour. Okay. TIC 48 is down 10 degrees and the controller output is 35. Remember, that is cascaded to our bottoms flow over here. Okay, FIC 45. So that those two are kind of linked together. And then the pressure indicator of the steam is down, way down low. It's not reading, it's about 30 psig, which means they're reading outside probably, because it's supposed to read between 100 and 200 and it's not reading at all. And then FI31, which is your input feed, the column halfway through to the column itself is normal. Okay, so let's see what we have. Now we're going to evaluate the data. Okay, so LIC 41 is at 100%. Okay, that's not expected because it's supposed to be running at 50. The output is near maximum. So FIC 40, which is the flow again to the steam to the reboiler, is near maximum. That's expected. The FIC 40 steam is near maximum and TIC 48 is low. So that's not what's expected there. And then the pressure indicator is also low. Again, not reading correctly, not what we expect. And our differential pressure is low. If we had a good steam and heat transfer in that column, we wouldn't see these low. The pressure is low because this differential pressure is low because there's probably not enough vapor being generated. FI31 is our input feed, and that's normal. FIC 45 is the column bottoms flow. That's low because we said it's coming off the temperature. And FI 47, which is to the overhead, are low, and that's not expected, especially when our input's in there normal. LIC 44, which is the level again in T1, that and PIC 43 outputs are reduced. It's what is expected with the low temperature though, and that's your process knowledge that you learn. All right, so let's evaluate this. Oops. Judgment. Yeah, there is a serious problem and a general condition. So the column appears to be slumping, right? It's indicating a near maximum steam at the reboiler, near maximum steam flow on the shell side, and the pressure is low. It's not logical. So we're going to continue to investigate. I'm going to just give you a tip here. This is something that you probably wouldn't really have thought about, so let's just go ahead and try anyway. Possible causes. Instrumentation. FIC 40, the valve has failed closed, right? That's our steam. All right, we think that might be one of the cases here. Mechanical. There could be a steam link between FV40 and E3. Okay, so that's between this valve and E3 if this valve isn't closed. There could be a steam link on the shell side of E3. We could be leaking condensate in E3 shell side. And then you could have a failed steam or condensate trap, allowing the steam pass through uncondensed. So this might be where all our steam's going out the window. That's something where I'm thinking, again, I would never have thought of that either. So I think this is an interesting problem. And we don't have any on the process side. All right, let's talk about the most probable causes of all those we just listed. Okay, FIC 40, the valve failure. Well, we decide that really probably is not true because we are showing a maximum steam flow. So it's going somewhere. Mechanical. Maybe it really is a steam trap failure and there's a leak that is just large enough to give you all these symptoms, and you can easily check that by going out and looking in the field at the steam trap itself. All right, so that's what we're going to decide that our corrective action. A leak would require a leak repair or shutdown of the repair. The steam trap repair may also require a shutdown. So you slowly close the valve in the steam trap line, okay, so you're partially blocking the shell side outlet, and then you're causing the back pressure in E3, and the steam should begin to condensate and give up the latent heat. Okay. So right now you're just in a little bit of a holding pattern. Okay, not what expected, right? So that's an interesting problem. I wasn't even thinking of a steam trap, so that's a good example there for you to try. All right, let's go to the next one. This is example 5, exercise 5.2 on page 5-43. All right, so again, here's all the listings of all the values, and we only have a couple things out on this one. So I'm just going to go right to that page. All right, let's look at data collection. So it seems as if a lot of things are okay. There's only a few that are not, so let's just talk about them. LIC 44, which is the T1 condensate tank, that level is okay, but the output is up by 10%. FIC 45, which is the FIC 45 is the column bottom flow is down, and the controller output is down 5%. The differential pressure across the column is fine. And then FIC 47, which is actually the condensate flow, is up 1400. And then TIC 48 is okay, but its output, it's running at the normal temperature, but its output is down 15%, which would drop this flow here down. Okay, so those two kind of work together. And the rest of the situation is normal. Now, if this controller here on the tank is also normal, but it's increasing it, that would also indicate this to be up. So we have a couple things that kind of make sense. Let's look at it and see. LIC 44 controller output is up 10%, which would cause that FI 47, which is the overhead condensate to a product storage, is up. That's expected. Now, TIC 48 controller output is down 15%, which would drive FIC 45 down. That's expected. The overhead flow is up 1400 and the bottom flow is reduced by 1500, so that's pretty close to being a material balance. And TIC output decreases with most of the columns normal. That's not expected. So this is really one of the issues here. TIC 48, what's going on? Why is that level of the temperature normal, but at the same time it's decreased? So let's see if we have a problem. So yeah, there is a problem. So TIC 48 reacted as if the temperature decreased in the column. It appears that there are more light ends and less high boilers. Let's investigate. All right, let's think about some possible causes. Instrument side. Again, this is one that I wasn't really exactly thinking of, and I was trying to figure it out, but it's a really good solution. When I see it, I think it makes the most sense, and we'll get to it. But I did come up with all of these possible causes. So you could have an error in the temperature controller, because if the controller is not working right, if the level is the same but the output's different, so that might be just an algorithm error. LIC41 also could be a problem where the level is reading incorrectly, which would also affect the temperature here as well. Then PIC43, which is the pressure of the actual column, could actually be low, allowing more material to go overhead. Okay, we could have a leak near the bottom of the column, or we could have a feed composition change, and that could probably really explain most of everything. So let's go through and see. What is the most probable causes? All right, instrument. So TIC48 error, well, we think that wouldn't be the case because it would cause a permanent change in the steam flow, or it would adjust the steam flow. The steam flow is okay. LIC41 error as well. No, it would change also, no change in the steam flow, and does not account for TIC48. Okay, so these again kind of work together. And then the column, pressure, no error, no change in the output either is what's going on there. Right, mechanical. A leak near the bottom, well, you can go out and check that right away, right? And field check would look and see that. Process, feed composition change. And this is extremely likely because it would do everything exactly as we thought. Because the sample's overhead, it would bring in a higher mixture of low boilers. So you wouldn't see any temperature change at the bottom, and you would have more, you would be making more product. Okay, so that makes very good sense. All right, so what you would do is you would call upstream of the unit and find out, if they change their composition, sample the overhead and the bottom products, and sample the feed. And then you could be prepared to shift to normal feed composition when you're done. Just ask them to call you back when it's ready. So that's pretty straightforward. Okay, so now review Chapter 5, those problems. There's another worksheet, 37 to 39. I want you to do that. I have all the answers posted, but I wanted to make sure you give a little time to go over them so the answers aren't available to you till April 12. And then test 4 will be due on April 22nd. So next week I'll hand it out to you, and it'll be due in another week, okay? Because today is April 8. Now continue on your capstone project, which is, again, your pros and cons for bioethanol. There is a lab today, and it's just the first part of the natural draft fired heater. And I want you to go over that and the what ifs, okay? And I printed out, I gave you access to the lab manual that you normally get the Simtronic, so you can answer all those questions. So I want that done too. All right? And I'll talk to you soon. Have a good one, you guys. Bye-bye.